The beginning of the universe. A calm journey through the birth of everything. Imagine for a moment that you could travel backward through time. Not just a few years or a few centuries, but billions of years into the past. Imagine leaving the familiar world of Earth behind and drifting outward into the vast darkness of space. The blue oceans of our planet slowly disappear beneath you. The moon fades into the distance. Soon, even the warm glow of the sun becomes just another star among countless others scattered across the night. Now continue the journey. The stars of our galaxy begin to thin. The spiral arms of the Milky Way stretch out around you like a luminous river of light. Then, gradually shrink as you travel farther away. Soon our entire galaxy becomes just one faint island among billions. If you continue traveling backward through time, the universe itself begins to look different. Galaxies grow closer together. The cosmos becomes denser, hotter, and younger. And if we go far enough back, about 13.8 billion years, we reach the moment when everything began. Scientists call this moment the Big Bang. But despite the name, the Big Bang was not an explosion in space. It was the beginning of space, the birth of time itself. Before this moment, the universe as we know it did not exist. There were no stars, no galaxies, no planets. There was not even empty space. All matter, all energy, and all of space-time were compressed into an incredibly small and unimaginably dense state. Physicists sometimes describe this condition as a singularity, a point where our current understanding of physics begins to break down. It is difficult, perhaps impossible, to truly imagine such a state. Without space, there is no distance. Without time, there is no past or future. And yet, from this mysterious beginning, the entire universe would emerge. Then, in the tiniest fraction of a second, everything changed. The universe began to expand. This expansion happened incredibly fast. In fact, during the earliest moment of cosmic history, the universe expanded faster than the speed of light in an event known as cosmic inflation. Within a tiny fraction of a second, space itself grew enormously. Something smaller than an atom expanded into something vast beyond imagination. This might seem strange, but it helps to imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. None of the dots sit at the center of the expansion. Instead, the surface itself is stretching. The universe behaves in a similar way. Space itself is expanding, carrying galaxies along with it. In the earliest moments after the Big Bang, the universe was incredibly hot, far hotter than the core of any star that exists today. At such extreme temperatures, matter could not exist in its normal forms. Atoms had not yet formed. Instead, the cosmos was filled with an energetic sea of radiation and fundamental particles. Quarks, electrons, and neutrinos moved through the young universe in every direction, colliding constantly within the intense heat. But as the universe expanded, it also began to cool. Slowly, conditions became calm enough for particles to combine. Quarks joined together to form protons and neutrons, the building blocks of atomic nuclei. For the first time, the ingredients for atoms began to appear. This was the first step toward everything that would eventually exist: stars, planets, oceans, mountains, and living creatures. Within the first few minutes of cosmic history, something remarkable happened. protons and neutrons began combining together to form the nuclei of the simplest elements: hydrogen, helium, and tiny amounts of lithium. This process is known as Big Bang nucleosynthesis. These early reactions produced nearly all the hydrogen that still exists in the universe today. The same hydrogen that fuels stars, the same hydrogen that forms the water in Earth's oceans. Even the atoms inside our bodies trace their origins back to this ancient moment in cosmic history. After only a few minutes, however, the universe had cooled enough that these nuclear reactions slowed dramatically. The creation of new atomic nuclei largely stopped. The young universe entered a long and quiet period of gradual change. Hundreds of thousands of years passed. During this time, the universe continued expanding and cooling. Eventually, it reached a temperature where electrons could finally combine with atomic nuclei to form stable atoms. For the first time in cosmic history, light could travel freely through space. This ancient light still fills the universe today. Astronomers detect it as the faint glow known as the cosmic microwave background. It is the oldest light we can observe, a relic from when the universe was only about 380,000 years old. Sensitive telescopes can detect this radiation coming from every direction in the sky. It is a quiet echo from the dawn of the cosmos. After this moment, the universe entered a long era of darkness. There were still no stars yet, no galaxies, only enormous clouds of hydrogen and helium drifting slowly through space. Gravity, however, was already at work. Tiny differences in density, regions where slightly more matter existed, began pulling surrounding gas toward them. Over millions of years, these regions grew larger and denser. Gas clouds collapsed under their own gravity. Temperatures deep inside these clouds began to rise, and eventually, after hundreds of millions of years, the first stars ignited. For the first time in cosmic history, the universe filled with light. These first stars were very different from the stars we see today. Because the early universe contained almost no heavy elements, the gas clouds that formed stars behaved differently. They tended to create extremely massive stars giants, far larger than our Sun. Some of them may have been hundreds of times more massive than the Sun. They burned fiercely and brilliantly, lighting up the young universe like cosmic beacons. But these giant stars lived short lives. Many lasted only a few million years before running out of fuel. When that happened, gravity crushed their cores, triggering powerful explosions known as supernova. These explosions scattered newly created elements across space: carbon, oxygen, iron, and many others. Those elements would eventually become the building blocks of planets and life itself. In a very real sense, the atoms that make up our bodies were forged inside ancient stars that lived billions of years ago. We are, quite literally, made of stardust. When the first stars appeared, the universe changed forever. For hundreds of millions of years after the birth of the cosmos, darkness had dominated everything. Vast clouds of hydrogen and helium drifted silently through space, slowly pulled together by gravity. But once the first stars ignited, the universe finally began to glow. These early stars were enormous. Because the universe contained almost no heavy elements at that time, the gas clouds that formed them behaved differently from the star-forming regions we see today. Instead of producing many small stars, the early universe often produced a few giant ones. Some of these stars may have been 100 or even 200 times more massive than our own Sun. Imagine a star so large that it would dwarf our entire solar system. These giant stars burned incredibly hot and bright. Their intense radiation began illuminating the young universe, slowly ending the long cosmic darkness that had lasted for hundreds of millions of years. But their brilliance came at a price. Massive stars consume their fuel very quickly. While our Sun will shine steadily for around 10 billion years, many of the first stars lived only a few million years before reaching the end of their lives. When that moment came, gravity began crushing the star's core with overwhelming force. The result was one of the most violent events in the universe. A stellar explosion known as a supernova. For a brief moment, the dying star could shine brighter than an entire galaxy. Shock waves raced outward through space, blasting the star's outer layers into the surrounding cosmos. But these explosions did something even more important. Inside those ancient stars, nuclear fusion had created elements that had never existed before. Carbon, oxygen, neon, iron. When the stars exploded, these elements were scattered across the universe, enriching the clouds of gas that would later form new stars and planets. Without those explosions, the universe would still contain almost nothing but hydrogen and helium. There would be no rocky planets, no oceans, no living organisms. In a very real sense, every atom of carbon in your body was once created inside a star that lived and died billions of years ago. As more stars were born and died, gravity continued shaping the structure of the universe. Stars rarely formed alone. They gathered together in enormous groups, bound by gravity into vast systems known as galaxies. A galaxy is like a cosmic city of stars. Some contain millions of stars, others contain billions. The largest galaxies may hold trillions. Over time, these galaxies began filling the universe like luminous islands scattered across a dark cosmic ocean. One of these galaxies would eventually become our home, the Milky Way. Today, the Milky Way stretches across roughly 100,000 light-years and contains hundreds of billions of stars. But in its earliest days, it was far smaller. Like many galaxies in the young universe, it grew slowly by merging with smaller galaxies drifting through space. When galaxies collide, something remarkable happens. Although billions of stars are involved, individual stars almost never crash into each other. The distances between them are simply too vast. Instead, gravity gently reshapes the galaxies, pulling their stars into new orbits and compressing massive clouds of gas. These compressed clouds often trigger waves of new star formation. Entire regions of space light up with newborn stars. Through billions of years of such mergers and transformations, galaxies grow larger and more complex. Even today, the Milky Way continues to evolve. Astronomers have discovered long streams of stars moving through our galaxy, remnants of smaller galaxies that were torn apart and absorbed long ago. The universe, it turns out, is always changing, even if those changes unfold slowly across millions or billions of years. At the heart of nearly every large galaxy lies something even more mysterious. Hidden deep within the glow of countless stars is an object so dense and powerful that not even light can escape its gravity. A black hole. Black holes form when enormous amounts of matter collapse into extremely small spaces, creating gravitational fields so intense that the fabric of space and time itself becomes distorted. In the center of our own galaxy lies a supermassive black hole, known as Sagittarius A star. This object contains about 4 million times the mass of the Sun. Yet it occupies a region of space smaller than the orbit of Mercury. Most of the time, this enormous black hole sits quietly at the center of the Milky Way. Stars orbit around it peacefully, much as planets orbit a star. But occasionally, gas or dust drifts too close. When that happens, the material spirals inward, heating up and releasing bursts of energy before disappearing beyond the black hole's event horizon. These energetic events can influence the evolution of entire galaxies. And yet, despite decades of research, black holes remain among the most mysterious objects in the universe. While galaxies were forming and evolving, the universe itself continued expanding. This expansion was first discovered in the early 20th century by the astronomer Edwin Hubble. While studying distant galaxies, Hubble noticed something remarkable. Nearly every galaxy he observed appeared to be moving away from us. The farther away a galaxy was, the faster it seemed to recede. This observation revealed a profound truth. The universe is not static. It is expanding. Space itself is stretching, carrying galaxies farther apart over time. And this expansion has been happening ever since the moment of the Big Bang. Even now, billions of years later, the expansion continues. Distant galaxies are drifting farther and farther away through the growing fabric of space. For many decades, scientists believed that gravity might eventually slow this expansion. After all, galaxies attract each other through gravity. Over immense timescales, that attraction might eventually halt the expansion and perhaps even cause the universe to collapse back inward. But in the late 1990s, astronomers made a surprising discovery. By observing distant exploding stars, they realized that the expansion of the universe is not slowing down. It is accelerating. Something mysterious is pushing galaxies apart faster and faster. Scientists call this unknown force dark energy. Today, dark energy appears to make up about 70% of the entire universe. Yet we still do not know what it actually is. It remains one of the greatest mysteries in modern science. If we could somehow zoom out, far beyond our galaxy, and look at the universe on its largest scales, we would see something beautiful. Galaxies are not scattered randomly through space. Instead, they form enormous patterns, known as the cosmic web. Long filaments of galaxies stretch across the universe like glowing threads, connecting massive clusters of galaxies. Between these filaments lie enormous empty regions, known as cosmic voids. Some of these voids span hundreds of millions of light-years. They contain very few galaxies at all. Together, these structures create the largest patterns known in the cosmos. And all of them grew from tiny fluctuations in matter that appeared shortly after the Big Bang. Small variations in density, barely noticeable in the early universe, were slowly amplified by gravity over billions of years. From those tiny beginnings emerged the vast cosmic structures we see today. As the universe aged, new generations of stars formed from gas enriched by earlier supernova explosions. Those stars contained heavier elements that the first stars lacked, and those heavier elements made something new possible: planets. Rocky worlds began forming from disks of dust and gas surrounding young stars. Some planets became giant balls of gas. Others became solid worlds of rock and metal. Moons formed, Asteroids drifted through young solar systems. Across the universe, planetary systems were beginning to appear. Billions of years after the universe was born, one such system would form within the quiet outer regions of the Milky Way. At its center would be a modest yellow star, a star we call the Sun, and around it would orbit a small blue planet that would eventually become home to life. But that story belongs to the next chapter of our cosmic journey. Billions of years passed as the universe continued its quiet transformation. Galaxies slowly grew larger. Stars were born, lived their brilliant lives, and eventually faded away. Across the immense darkness of space, gravity shaped the cosmos into structures of breathtaking scale. Yet while these grand events were unfolding across billions of light years, something equally remarkable was beginning to happen inside the galaxies themselves. The universe was learning how to build worlds. In the earliest generations of stars, there had been almost nothing except hydrogen and helium. But with every passing era, stellar explosions enriched the cosmic gas with heavier elements: carbon, oxygen, silicon, iron. These elements changed everything. Gas clouds containing heavier elements cooled more easily and collapsed more efficiently. Around many young stars, swirling disks of dust and gas began to appear. These disks became the birthplaces of planets. Tiny grains of dust drifted through the disk, occasionally colliding with one another. At first, these collisions created only microscopic clumps. But over time, those clumps grew larger. Dust became pebbles. Pebbles became rocks. Rocks gathered into mountain-sized bodies known as planetesimals. Gravity slowly pulled these bodies together, forming larger and larger worlds. Over millions of years, entire planetary systems emerged from the quiet, spinning disks around newborn stars. Today, astronomers have discovered thousands of such worlds orbiting distant stars. These planets are known as exoplanets, and their diversity is astonishing. Some are giant gas worlds, larger than Jupiter. Others are rocky planets, not much bigger than Earth. Some orbit scorchingly close to their stars, completing a full year in only a few days. Others drift through deep, cold darkness, far from their suns. A few may even possess conditions suitable for life. The universe, it seems, is filled with planets. Among the countless stars scattered across the Milky Way, one particular cloud of gas and dust began collapsing about 4.6 billion years ago. This cloud was not especially unusual. It was simply a small region within a much larger molecular cloud drifting through one of the galaxy's spiral arms. Perhaps a nearby supernova shockwave disturbed the cloud. Perhaps gravity slowly destabilized it over time. Whatever the cause, the cloud began to collapse inward under its own gravity. As it collapsed, the center grew denser and hotter. Eventually, nuclear fusion ignited in the core of the forming star. A new star was born. That star would eventually become our Sun. Around the young Sun, the remaining gas and dust flattened into a spinning disk known as the protoplanetary disk. Within this disk, the same process that had occurred around countless other stars was beginning again. Dust grains collided and stuck together. Small clumps grew larger. Over time, these clumps became the seeds of planets. But the environment near the young Sun was not calm. The early solar system was chaotic and violent. Planetesimals collided constantly, sometimes merging together and sometimes shattering into fragments. Enormous impacts reshaped the growing worlds. Some bodies were thrown outward into the distant regions of the solar system. Others spiraled inward toward the sun. Through this turbulent process, the major planets slowly emerged. Closest to the sun, rocky worlds formed: Mercury, Venus, Earth, Mars. Farther away, where temperatures were colder, enormous gas giants took shape. Jupiter and Saturn grew massive enough to capture thick atmospheres of hydrogen and helium. Beyond them, the icy giants Uranus and Neptune formed in the distant cold. Together, these worlds became the solar system. Among these forming planets, one small world occupied a particularly interesting location. It orbited at just the right distance from the sun. Not so close that its oceans would boil away, not so far that its surface would freeze solid. This region is sometimes called the habitable zone. Within this gentle range of temperatures, liquid water can exist on a planet's surface. The small rocky planet in this region would eventually become Earth. But the early Earth looked nothing like the peaceful blue planet we know today. In its infancy, Earth was a molten world. Its surface was covered in oceans of magma. Volcanoes erupted constantly, releasing gases into the young atmosphere. Meanwhile, enormous asteroids and comets frequently struck the planet, delivering additional material from across the solar system. One of these impacts may have been the most important event in Earth's early history. Scientists believe that a Mars-sized object collided with the young Earth roughly 4-5 billion years ago. The impact was catastrophic. Debris blasted into space, forming a glowing ring of molten rock around the planet. Over time, this material slowly gathered together, forming Earth's natural satellite, the Moon. The Moon would play an important role in stabilizing Earth's rotation and influencing the tides of its oceans. Without it, our planet might have evolved very differently. As millions of years passed, Earth gradually cooled. The molten oceans hardened into solid crust. Volcanic gases accumulated in the atmosphere. Water vapor condensed into clouds. Eventually, rain began to fall. Not for hours or days, but for thousands of years. Slowly, the first oceans formed. For the first time in the history of the universe, conditions existed that might allow life to emerge. Somewhere within the warm, ancient oceans, simple molecules began interacting in increasingly complex ways. Energy from sunlight, volcanic activity, and lightning powered chemical reactions in the primitive seas. Over immense spans of time, these reactions produced molecules capable of copying themselves. At some point, chemistry crossed a remarkable threshold. It became biology. Life had appeared on Earth. The earliest life forms were extremely simple. They were microscopic organisms, similar to modern bacteria. Yet even these tiny organisms would eventually transform the planet. For billions of years, life remained confined to the oceans, slowly evolving and adapting to the changing conditions of the young Earth. Some early organisms developed the ability to capture energy from sunlight through photosynthesis. This process released oxygen as a byproduct. At first, the oxygen reacted with minerals in the oceans and crust, but eventually, oxygen began accumulating in the atmosphere. This event, known as the Great Oxygenation Event, dramatically changed Earth's environment. Oxygen made it possible for more complex life forms to evolve. It also created a protective ozone layer in the upper atmosphere, shielding the surface from harmful radiation. Over the next billions of years, life on Earth would slowly diversify. Simple cells would give rise to complex organisms. Multicellular life would eventually emerge. Plants would colonize the land. Animals would evolve in the oceans and later walk upon the continents. Dinosaurs would rule the planet for millions of years before disappearing in a cosmic catastrophe. And much later, a species capable of looking up at the night sky and wondering about the universe would appear. Human beings. Today, when we look out into the darkness of space, we are witnessing a story billions of years in the making. Every star we see is part of that story. Every galaxy, every atom in our bodies, all of it traces back to the same ancient beginning nearly 13.8 billion years ago. The universe began as a tiny, unimaginably hot state. It expanded, cooled, and slowly built the structures we see today. Stars ignited, galaxies formed, planets emerged, and on at least one small world, life awakened and began asking questions about the cosmos. We are part of that cosmic story, a very small part perhaps, but a remarkable one, because the universe has become aware of itself through us. And every time we gaze at the stars, we continue the journey that began with the Big Bang. If we pause for a moment and look back across the entire history of the universe, something extraordinary becomes clear. From a tiny beginning nearly 13.8 billion years ago, the cosmos has slowly transformed into a vast and intricate tapestry of galaxies, stars, planets, and life. But the story of the universe is not finished. In fact, we are living at a very special moment in cosmic history. Stars still shine brightly across the galaxies. New stars are still being born from clouds of gas and dust. Planetary systems continue to form, and the universe remains filled with light and activity. Yet this era will not last forever. The cosmos is constantly changing, even if those changes occur across timescales far longer than a human lifetime. To understand what the future may hold, astronomers look at how stars live and die. Every star begins its life when a cloud of gas collapses under gravity. As the material gathers together, the center becomes hotter and denser until nuclear fusion ignites. From that moment on, the star begins converting hydrogen into helium, releasing enormous amounts of energy in the process. This steady fusion is what allows stars to shine for millions, billions, or even trillions of years. Our own sun is currently in the stable middle phase of its life, known as the main sequence. During this long period, it will continue shining steadily for roughly another 5 billion years. But eventually, the sun's core will run out of hydrogen fuel. When that happens, gravity will begin compressing the core once again, while the outer layers of the star expand dramatically. The sun will grow into a red giant. At that stage, it may expand far enough to engulf the inner planets of the solar system. Mercury and Venus will almost certainly disappear inside the sun's outer atmosphere. Earth's fate is less certain, but even if our planet survives the expansion, its surface will be transformed into a lifeless world of extreme heat. After this brief but dramatic phase, the sun will shed its outer layers into space, creating a glowing cloud of gas known as a planetary nebula. At the center of that expanding cloud, the remaining core of the sun will remain behind as a small, incredibly dense object called a white dwarf. This remnant will slowly cool and fade over billions of years. The sun's life cycle is not unusual. Across the Milky Way, billions of stars are currently moving through similar stages of evolution. Some stars are smaller and will burn their fuel extremely slowly, potentially shining for trillions of years. Others are far more massive and live very short lives before exploding in spectacular supernova events. But eventually, every star will reach the end of its life. Over extremely long periods of time, the universe will gradually run out of the gas needed to form new stars. Astronomers believe that star formation in most galaxies will slow dramatically within the next few 100 billion years. Without fresh clouds of gas collapsing into new stars, the universe will slowly grow darker. This distant era is sometimes called the stelliferous era, the age of stars. We are currently living within this long epoch, but eventually it will come to an end. Long after the last new stars have formed, the universe will enter a very different phase. Galaxies will still exist, but most of their stars will be ancient and fading. White dwarfs, neutron stars, and black holes will dominate the cosmic landscape. Over unimaginable spans of time, gravitational interactions will slowly disrupt the structure of galaxies themselves. Stars may be ejected into the vast emptiness between galaxies. Others will drift closer to the massive black hole lurking at the center of their galaxy and eventually be consumed. Even the great spiral structure of the Milky Way will eventually change. In fact, long before that distant future arrives, our galaxy will experience an enormous cosmic event. Roughly 4 billion years from now, the Milky Way will collide with its neighboring galaxy, Andromeda Galaxy. From a human perspective, the word collision sounds violent and chaotic, but because galaxies are mostly empty space, the encounter will unfold slowly over millions of years. The two galaxies will pass through each other several times, their gravitational forces pulling long streams of stars across space. Eventually, the two systems will merge together into a single, much larger galaxy. Astronomers sometimes call this future galaxy Milkomeda. From Earth's perspective, if our planet still existed at that time, the night sky would look extraordinary. The spiral arms of Andromeda would stretch across the heavens, gradually blending with the stars of the Milky Way. Over time, the two galaxies would settle into a new shape, most likely becoming a giant elliptical galaxy filled with aging stars. Meanwhile, the universe itself will continue expanding. This expansion, driven by the mysterious force known as dark energy, will slowly push galaxies farther apart. In the far future, distant galaxies will drift so far away that their light will no longer reach us. Observers living in the merged Milky Way Andromeda Galaxy might one day see a universe that appears almost empty. The vast cosmic web of galaxies that currently fills the observable universe would gradually disappear beyond the cosmic horizon. Future astronomers, if any exist, might find it difficult to even discover that other galaxies once existed. The universe will grow quieter, darker, colder, and yet, even in this distant future, the universe will not be completely still. Black holes will continue influencing their surroundings. Small interactions between stars and stellar remnants will slowly reshape galaxies. Over timescales far beyond anything we can easily imagine, trillions upon trillions of years, the cosmos will continue evolving. Some stars will remain faintly glowing. White dwarfs will cool. Neutron stars will slowly spin down. Black holes will remain as some of the last powerful structures in the universe. But even they may not last forever. Long ago, the famous physicist Stephen Hawking proposed that black holes are not entirely black. According to the strange rules of quantum physics, black holes may slowly lose energy through a subtle process now called Hawking radiation. Over incredibly long periods of time, far longer than the current age of the universe, this process could cause black holes to slowly evaporate. The largest black holes might take more than 110 to the power of 101,000 years to disappear. But eventually, even these massive objects may fade away. If that happens, the universe could enter an era where almost nothing remains except extremely low-energy particles drifting through an ever-expanding space. This hypothetical period is sometimes described as the dark era of the universe. And yet, even when imagining such distant futures, it is important to remember something remarkable. All of this, the stars, the galaxies, the planets, and the life that emerged on at least one small world, began from a single cosmic event, the Big Bang. From that mysterious beginning, the universe has grown into a place of extraordinary beauty and complexity. And somewhere within that vast cosmic story, a small blue planet formed around an ordinary star. On that planet, life emerged. And eventually, that life developed the ability to look upward and wonder, to ask questions about where it came from and where the universe might be going. If we step back and look at the entire journey we have traveled, the story of the universe begins to feel almost like a slow, unfolding dream. From a moment of unimaginable heat and density nearly 13.8 billion years ago, the cosmos expanded into the vast ocean of space we know today. At first, there was only energy and the simplest particles. Then atoms formed. Later came stars, galaxies, and the great structures that stretch across billions of light years. Over immense spans of time, the universe learned how to create complexity. Stars forged heavy elements in their blazing cores. Exploding supernovae scattered those elements across space. New generations of stars were born, surrounded by swirling disks of dust and gas. Within those disks, tiny grains collided and slowly assembled into planets. And on at least one small planet orbiting a modest yellow star, something extraordinary happened. Life appeared. That small planet is Earth. For billions of years, life evolved quietly in its oceans and on its continents. The atmosphere changed. Oceans shifted. Continents drifted slowly across the planet's surface. Creatures appeared, adapted, and vanished again as time marched steadily forward. Eventually, one species developed something unique, the ability to wonder. Humans began looking up at the night sky thousands of years ago, long before telescopes or modern science. The stars seemed mysterious and eternal. Ancient civilizations built myths and stories to explain their presence. But over time, curiosity led to deeper questions. What are the stars? How far away are they? What is the universe made of? And where did everything come from? During the last few centuries, our understanding of the cosmos has grown enormously. With the invention of telescopes, astronomers began discovering that the universe was far larger than anyone had imagined. Our Milky Way galaxy, once thought to be the entire universe, turned out to be only one galaxy among billions. In the early 20th century, astronomers discovered that distant galaxies are moving away from us, revealing that the universe itself is expanding. Later observations uncovered faint radiation filling the cosmos, the cosmic microwave background, a quiet echo from the early universe. These discoveries helped confirm the remarkable idea that the universe had a beginning, the Big Bang. Even today, Scientists continue searching for answers to the deepest cosmic mysteries. What exactly happened in the first moments after the universe began? What is the true nature of dark matter, the invisible substance that seems to hold galaxies together? And what is dark energy, the mysterious force accelerating the expansion of the universe? These questions remind us that despite all we have learned, the cosmos still holds many secrets. Yet perhaps the most remarkable part of this entire story is that the universe has produced beings capable of asking these questions at all. Think about the long chain of events that made this possible. Stars had to form and live long enough to create heavy elements. Those elements had to gather into planets. A planet had to orbit at just the right distance from its star. Life had to begin and survive countless challenges across billions of years. Evolution had to produce intelligent organisms capable of observation, imagination, and scientific thinking. All of these events are connected. They form an unbroken chain stretching from the birth of the universe to the present moment. When we look up at the night sky, we are not separate from the cosmos. We are part of it. The atoms in our bodies were forged in ancient stars that lived long before our planet existed. The calcium in our bones, the oxygen we breathe, the carbon in every living cell, all were created inside stars that exploded billions of years ago. In a very real sense, we are the universe observing itself. Tonight, somewhere beneath the quiet glow of the stars, a child may be looking up at the sky for the first time and wondering what lies beyond. Perhaps they notice the soft light of the moon rising above the horizon, or they trace the faint band of the Milky Way stretching across the darkness like a river of light. They might not yet understand the vast distances involved, or the billions of years of cosmic history hidden within that light. But the feeling of wonder is the same feeling that has inspired scientists, philosophers, and explorers for generations. Wonder is often where discovery begins. And when we think about the universe as a whole, we realize that it is not only vast, but also incredibly quiet. Between the galaxies lies an immense darkness. Between the stars stretch distances so great that light itself may take thousands or millions of years to cross them. Yet within that silence, the universe continues its slow transformation. Stars ignite, galaxies merge, planets form, life evolves. And somewhere, intelligent beings look upward and ask questions about the nature of reality. Perhaps on distant worlds orbiting other stars, other civilizations are also exploring the same mysteries. They may be gazing at their own night skies, wondering how the universe began and whether anyone else is out there. The cosmos is so large that it may contain countless such stories unfolding simultaneously. For now, however, our story belongs to this small planet, a world of oceans and clouds drifting quietly around the sun. From this tiny vantage point within a spiral arm of the Milky Way, humanity has begun exploring the universe with telescopes, spacecraft, and scientific curiosity. We have sent robotic explorers to the Moon, to Mars, and beyond the outer planets. Space telescopes peer deep into the cosmos, revealing galaxies whose light began its journey billions of years ago. Each new discovery adds another piece to the puzzle of our cosmic origins. And the journey of discovery is only just beginning. So tonight, as the universe continues its silent expansion, the stars above us shine with ancient light. Some of those photons began their journey before Earth even existed. Others left distant stars while the earliest humans were learning to walk upright on the African savannas. And still others are arriving right now, traveling across the darkness of space to reach our eyes. Every glance at the night sky is a glimpse into the past, a reminder that we are connected to something far larger than ourselves. The universe is vast, mysterious, and still full of unanswered questions, but it is also beautiful. And somehow, within all that cosmic complexity, it has given rise to life, awareness, and curiosity. The story of the universe continues. Stars will continue to shine. Galaxies will continue drifting across the expanding fabric of space. And somewhere, perhaps on this planet or another, new minds will continue asking the timeless questions: where did we come from? What is the universe made of? And what wonders still await discovery among the stars? For now, we can simply look up at the night sky and remember that the journey of the cosmos began with a single moment, a moment that changed everything, the moment we call the Big Bang.